Howdy, Chemsters. I want to go ahead and go over a heating curve with you, as we did in class today. And you should draw this out so that you can add all these pieces and make sure you understand what this heating curve is showing you. This is a heating curve for water, H2O, but there are heating curves for other substances as well, and their critical temperatures are not necessarily the same as the critical temperatures listed for water. So notice on this heating curve, on the x-axis is time, and on the y-axis is temperature. The temperature here is listed in Celsius, okay? Degrees Celsius is the temperature. And the time would typically be in minutes. And every minute, somebody could go ahead and take a reading. And as you continue with the heating of the substance, which in this case is water, you would see a curve begin to develop. So on this particular curve, I'm going to pretend that I am starting at, say here, which would be about -30. And then what I notice is that throughout the time that I am heating, my curve, as I plot the temperature, continues to go up, 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 and up. And then what I notice is that right around 0 degrees Celsius, my curve begins to flatten out or have a plateau. And that flat place, you might have already known, this place here is 0 degrees. This is considered the melting point, also the freezing point of water. So water freezes at 0 degrees C, 32 Fahrenheit. And that's what I notice about my curve here. So in segment 1 of my curve, if I were to label my segment, I have water in the solid phase, which I call ice. That's the common name of it, right? And the ice, so this is solid water, is warming up. How do I know it's warming up? Because if you look, as I go up this part of the curve, the temperature is increasing. So this is ice, and the ice is warming up. That means as I started my heating curve and I took the ice and I went ahead, let's say I went ahead and I have ice, maybe little blocks of ice, and I put a flame underneath it. So while I'm doing that, I'm adding heat all the time while this heating curve is taking place. So I started with ice at -30. I keep adding heat, and keep adding heat. And what I end up showing is that as I add heat, my curve is rising. My particles of ice are gaining energy. But at 0, something very interesting happens to the curve. Now this is segment 2 of my curve. And you might already notice, because you know that the freezing point and melting point means that my solid ice is now going to melt into liquid water. So now we have water solid changing to water liquid. So this place on the curve right here at point 2 is actually the process of melting. Melting is taking place right now as I'm heating. If I were cooling, though, it would be different. I could actually freeze it at that point. So freezing and melting are opposites of each other. Melting is when you are adding heat, warming something up, and freezing takes place when you are removing heat from the system. All right, what happens next? So notice from my graph, time's going by. I'm adding heat, and my ice is warming up. And then eventually I see that it begins freezing. It begins melting. And it keeps melting all through this part of the curve that is flat. Okay? And not until all of it has melted, solid, changing into liquid, will it begin to change again in temperature. Once the whole solid melts, then I will see a rise in temperature again. And it will keep rising, keep rising, keep rising, keep rising, until it gets to another very important temperature in ice's life, or rather water's life, 100 degrees, because most people know that that is the boiling point for water. So during segment 3, I have water in the liquid form warming up all throughout this segment of my heating curve. Remember, I started with ice. It warmed up, warmed up, warmed up. It melted. And then I finally, when I finished melting, the liquid water warmed up, warmed up, warmed up, warmed up, warmed up. And now it is going to go to another phase change right here. And that phase change is where a liquid changes to a gas. We could call that boiling. Sometimes vaporization might be used for that possibly as well. So section 4 of my curve is boiling taking place. So right at the beginning of this, when it reaches 100 degrees, right at the beginning of this, my liquid is now beginning to vaporize. And all throughout this section of the curve, it is vaporizing, vaporizing, vaporizing. At the end of this section of the curve, all of it has vaporized. Okay? And only then can the next section, section 5, occur. Section 5 is where you now have gas. Right here you had liquid, and right here you had solid. This is where the gas can actually warm up above 100. Okay? So at what point is boiling taking place? Right here. At what point is melting taking place? Right here at 0. And would this require energy, or would it, so in other words, would you put in heat or would you take away heat? Would heat be absorbed or released? Hopefully you're gathering by the fact that it's a heating curve, that the whole way as we go through this process of heating, melting, heating, boiling, and heating, this is endothermic. Endothermic, because heat is going in order for the water, solid, ice, to pass through these stages as it warms up. So all of these processes that were involved, which we said were melting and boiling, these are endothermic. If we were to go the other direction, though, and allow this gas to begin cooling, all the way down to, we would have to cool it all the way down to solid. Those processes are exothermic. So the opposite of boiling is condensation or condensing. Condensing would be releasing heat, exothermic. Freezing would be releasing heat, exothermic. So when you take in heat, you're warming. And when you release heat, you're cooling. And the particles are slowing down. When you go from a gas to a liquid and then to a solid, those particles are slowing down. And that's why it is releasing heat, exothermic. I hope this makes sense. I want to show you what this would look like if I graphed it in the lab. In fact, this is one of my graphs from class. What I start with is I start with a beaker, and in that beaker I just put ice, okay? And then what I do is I put it on the hot plate, which is a device that heats it, and plug it in. And basically heat is going in to the ice. Ice is absorbing heat. And when I very first start this process, you'll notice if you look at the timing, I needed to go for about 50 minutes to an hour of time to finish this curve. And by the way, you might be wondering why this tiny little blip happened. I was readjusting the thermometer. So I have a thermometer that's connected to the computer. It's a probe, and I have the thermometer into here, and it's taking a temperature reading every minute. And then this is plugged in to my computer so that I can graph right away my results. So what I noticed is, and look at all of my numbers and look at the graph. So you see here, the whole time it's at 0, even though heat is being added, the curve remains flat. This is where the solid is becoming a liquid at 0 degrees Celsius. The whole time that this phase change is taking place, I am staying at 0. And once I finish my phase change, then you'll notice that the liquid that is now there begins to heat. This is liquid water heating up. And then eventually, when I get to a high enough temperature, 100 degrees Celsius, you'll see that, if you were in the room with me, that this liquid water in the beaker now begins to become gas, and you'll be able to see the vapor, the steam coming off of that. And this is a different phase change. This is where a liquid becomes a gas. We call that boiling. Whereas this one is called melting. Just like the picture I showed you a minute ago. Except the part that we're watching and looking at is only this part right here. Let me use a different color so you can see what I'm talking about. The only part we saw was this and this and this in real time in the lab. All right? So it's important that you know, same thing going on here. This is your melting point, 0 degrees. This is your vaporizing or boiling point, 100 degrees. So keep in mind that fusion, which is another word for melting, is the opposite of freezing. So if you were warming up, you would melt the solid to become liquid. If you were cooling it down, you could freeze the liquid to become solid. Melting and freezing are two different processes that happen at the same exact temperature. And that temperature is called the melting point. And it happens to be, for water, 0 degrees. So if you're warming it up, it'll melt at 0. And if you're cooling it down, it'll freeze at 0. Now, vaporization is another word for boiling. It means changing it to a gas. So if you're heating it up, it will boil. But if you're cooling it down, that would be called condensation. Hopefully that helps a lot in your understanding of heating curves. Bye-bye.